we're going to continue our discussion about rational functions graphs, and today we're going to focus solely on the slant asymptote, or also called oblique asymptote. And all these problems here are going to have those slanted or oblique asymptotes. So when we have those, we have to make sure we use long division, and that is our asymptote. And because the degree of the numerator is bigger than the degree of the denominator by 1, remember that's what we have right here, then the quotient will always be linear, and we're going to graph that line, and that is our asymptote. So none of these are going to have horizontal asymptotes. It will always be, these ones will always be slanted ones. Now, you might say, well, what do we compare then to for the end behavior? So for end behavior, for end behavior, we are going to compare f of negative 1,000 and f of positive 1,000 to the slant asymptote or oblique asymptote. So we're going to evaluate that asymptote at negative 1,000 and positive 1,000, and that's what we're going to compare f of negative 1,000 and f of positive 1,000. So when we graph these, we're still going to do all the same steps that we've done before. We're going to factor the numerator and denominator here. So we have x squared plus 5x plus 4. That factors to x plus 4 times x plus 1. The denominator is just x minus 3. We want to factor the numerator and denominator, again, just to see if we have anything that cancels out, which would give us a whole. Then our x-intercepts are going to be when the numerator is equal to 0. So that is going to be at negative 4 comma 0 and negative 1 comma 0. Then y-intercept, or y-intercept is f of 0, which equals 0 plus 4 times 0 plus 1 over 0 minus 3, and that gets us 4 over negative 3. So our y-intercept is 0 comma negative 4/3. Let's find our vertical asymptote. Vertical asymptote is what makes the denominator equal to 0, so x equals positive 3. And there is no horizontal asymptote because the degree of the numerator is larger than the degree of the denominator. So no HA. None. So now we're going to calculate the slant asymptote by using long division. So x minus 3 divided by x squared plus 5x plus 4. And we'll divide this, and x goes into x squared, x times. Oops. X times x is x squared. X times negative 3 is negative 3x. Then we subtract. This will give us 8x. 8x, and then we bring down the positive 4. All right, x goes into 8x 8 times. So then we get 8x minus 24. And then when we subtract, we get positive 28 as a remainder. Now, like I said, the remainder doesn't matter. It's this part right here. This is our oblique or slanted asymptote. All right, now we have to do the vertical behavior. So our slant asymptote, let's see where I want to write this. Slant asymptote is x plus 8. vertical behavior. All right, our asymptote is at x equals positive 3. So we're going to do f of 2.9. And that will give us 2.9 plus 4 times 2.9 plus 1 over 2.9 minus 3. So the numerator is going to be positive because we just have addition and we're adding a positive 2.9. The denominator is going to be negative because 2.9 minus 3 gives us a negative value. So negative, which means the left side goes down. And we know that since the multiplicity of our asymptote down here is 1, that the other end must go up because the end's going opposite directions with odd multiplicities. Or you could substitute in 3.1 if you wanted to. And you will see that you will get a positive, you'll get a positive value, so the right side up. All right, we're almost done now. The last thing we have to do is our end behavior. So we have to first evaluate the slant asymptote at negative 1,000. So negative 1,000 plus 8 is negative 992. And then we have to evaluate the slant asymptote at positive 1,000. 1,000 plus 8, 1,008. So when we do our end behavior and we substitute negative 1,000 in for f and positive 1,000 into f, we compare them to these numbers for above or below. So f of negative 1,000 is equal to negative 1,000 plus 4 times negative 1,000 plus 1 over negative 1,000 minus 3. When I type that into the calculator, I get negative 992.027, which is less than negative 992. So the left side is going to be below the asymptote. Then we're going to substitute in positive 1,000. So 1,000 plus 4 times 1,000 plus 1 over 1,000 minus 3. And I get 1,008.028, which is larger than 1,008, so above. So it's important that you match things up, where the slant asymptote at negative 1,000 is compared to f evaluated at negative 1,000, and the slant asymptote at positive 1,000 is compared to the slant asymptote at positive, or the function at positive 1,000. All right, so now we have all our information and we're going to start with our sketch. All right, we have our x-intercepts at negative 4, 0 and negative 1, 0. We have our y-intercept at 0, negative 4/3, which is a little bit smaller than negative 1. We have our vertical asymptote at x equals 3. And now our slant asymptote is the equation x plus 8. So let's go up to 8 on the y-axis. 1, 2, 3, 4, 5, 6. And a slope of x means up 1 and right 1. So our slant asymptote is like this. So the left side of the graph, we have the left side goes down towards the asymptote. Oops. Let me draw that a little bit. Like that. And the left end behavior stays below our asymptote. So it's going to come up and back down. It looks something like that. Then this part over here is going to be above the asymptote and then go up. So as weird as that graph looks, that's the correct graph for this function with that slant asymptote. So yeah, this area here is completely barren. There's nothing going on there because we have those two x-intercepts that we have to connect. All right, so this graph here, x squared minus 3x minus 4 over x squared minus x minus 12. What we're going to do with that is first we're going to factor the numerator and denominator. The numerator is going to factor into x minus 4 times x plus 1, and the denominator is going to factor to x minus 4 times x plus 3. So notice that these two are going to cancel. So that means we're going to have a whole at x equals positive 4. So I want to write that down so I don't forget it. All right, so now the x-intercepts, we look at our factored form and say what makes our numerator equal to 0. So x plus 1 equals 0, x equals negative 1. So negative 1 comma 0 is the x-intercept. Now the y-intercept, that's f of 0. So I could use the original, or I could use the factored one, 0 plus 1 over 0 plus 3, which is 1/3. So 0 comma 1/3 is my y-intercept. Right, now our vertical asymptotes, we're only going to have one, as x equals negative 3, because I've already accounted for x minus 4 being a domain restriction because of the whole, and what's left is the x plus 3 factor, so vertical asymptote at x equals negative 3. And then a horizontal asymptote at y equals the ratio of the leading coefficients, because we had x squared over x squared. The degrees are the same, so it's 1 over 1, or 1. So let's go ahead and draw those. And plot, negative 1 comma 0, the x-intercept, and 0 comma 1/3. Now, you may think that this goes like that, and you might be correct at this point, but remember, you are allowed to cross a horizontal asymptote, so this may go above like that. So we want to make sure that we still do the end behavior just in case. Right, so our vertical behavior, so what's happening on each side of the asymptote, so f of, and we're going to go slightly smaller, so negative 3.1, and we're going to substitute that into the factored form, x plus 1 over x plus 3. So negative 3.1 plus 1 over negative 3.1 plus 3. And again, we're only concerned, is this positive or negative? Okay, so the numerator is going to be negative. The denominator is going to also be negative. Negative divided by negative is positive. So that means the left side is going to go up. Now we're going to do f of negative 2.9, something slightly bigger than negative 3. So negative 2.9 plus 1 over negative 2.9 plus 3. Numerator is still negative, but the denominator is going to be positive, which equals a negative value. So that means the right side is going to go down. All right, now for the end behavior, we are going to substitute in negative 1,000 and 1,000. So f of negative 1,000 is equal to negative 1,000 plus, plus 1, the numerator is plus 1, over negative 1,000 plus 3. So like how we talked about the other day,
we want to type this into our calculator, and I'm doing that off screen here. So negative 1,000 plus 1, enter, and then negative 1,000 plus 3. And when you divide those, you are going to get 1.002. Now, we compare that to the horizontal asymptote, which is y equals 1. That's bigger than 1, so it's going to be above. Now we're going to do the same thing with negative 1,000. Sorry, not negative, positive 1,000. 1,000 plus 1 over 1,000 plus 3. And that one's maybe a little bit easier to do in your calculator. I get 0.998, which is less than 1, so it's below. Okay, so now back to our graph. On the left side, the left end behavior has to be above the horizontal asymptote, and as I approach my vertical asymptote, the left side of that we're going to go up. And it turns out maybe your prediction about the right end behavior was correct, or your branch, because we are, on the right side, we are below the horizontal asymptote, and then as we get to the vertical asymptote, our right side's going down. So this is how that graph looks like, but remember we have a hole at x equals 4. So I want to go back and at x equals 4 here, 1, 2, 3, 4, I want to put an open circle to note that there's a hole there. So yeah, this graph looks exactly like if you were to put this in the graphing calculator, it would look just like this, but we wouldn't be able to see the hole in there, and that's why we account for it in our drawing with an open circle like that. All right, now let's go to the next page. We have x squared minus 8x plus 12 over x minus 6. Now, the numerator degree is bigger than the denominator, so that makes you think that there's an oblique asymptote. But let's factor the top and bottom and see what happens. So the numerator is x minus 6 times x minus 2 over x minus 6. Now the x minus 6's are going to cancel. Okay, so that means there's a hole at x equals 6. Now, you might say, well, now there's nothing in the denominator. Like, do we have vertical asymptotes? Do we have horizontal asymptotes and all that? No, we don't. Like, we can now treat this as the line x minus 2. We know how to graph x minus 2. We have a y-intercept at negative 2 and a slope of 1, up 1 and right 1, up 1 and right 1. We just have to remember that when we get to 6, x equals 6, so 1, 2, 3, 4, 5, 6, we have a circle there or a hole in the graph to note that. Now, we do not have to do end behavior, vertical behavior, or anything like that for this example because of canceling out that factor gives us an x minus 2 result. That's a line. So here, when we canceled, we still had a rational function. That's why we couldn't do what we just did in example number 3. In example number 1, we had that oblique asymptote that we got by long division, and then we compared our end behavior to that asymptote evaluated at negative 1,000 and positive 1,000. So if you need to go back and review example 1, because some of your homework problems are like that, go ahead and do that. But I just wanted to show you how don't get lost in the weeds here and thinking that all of these functions are going to look like this rational function. Like this one just looks like a line because we were able to cancel things out. So that's it. Thank you for watching. Make sure to like and subscribe.